what really fascinated me when I began to learn, when I had that first thought about resource flows, was how does the global economy function? And as an individual, my life had been sailing, I knew nothing about that, and I set about a new journey of learning. I started speaking to experts, scientists, economists, looking at how materials flow through the economy, how energy flows through the economy. And one thing really struck me back in 2006, 7, 8, when I was doing my initial research, was that so much of the narrative, knowing that we have finite resources, knowing we only have these materials, copper, indium, metals, once in the history of humanity, these materials are precious, we knew that, but our strategy was to use less, it was to be efficient. And although being efficient is absolutely vital if we have a finite resource, what struck me was it wasn't the solution. Because just being efficient every year with what we use doesn't solve the problem, it buys us time. And the niggling thing in my mind was what works? What system can actually really function in the long term? What could that look like? And our current economic system is very linear. It doesn't matter if you take fertilizer or soil or products like metals, plastics that we make big machinery out of. We take a material, we turn it into something, and then that product eventually gets thrown away. Yes, we recycle some of it, but not by intention. We try and get what we can out at the end. It's very linear, like a conveyor belt. And on this journey, I started to speak to people who saw things in a very different way, people who'd been working on ideas such as cradle-to-cradle design, industrial symbiosis, biomimicry, sharing economy, performance economy, ideas whereby you would keep products and components and materials at their highest value and utility at all times. You design waste out of the system entirely. Why would we ever create waste? We have nowhere to put it. We don't have a bin. We don't have a global bin. We have materials. Why would you ever take a valuable material and turn it into something which is effectively useless? And this was a very different way of looking at the economy. This was a circular economy. This was an economy whereby, by design, you would redesign the entire economic model so products, components, and materials would be kept to their highest value and utility at all times. And once you start thinking that, you look at the entire economy through a different lens. What would the automobile sector look like if you were able to do that, if you could recover all the materials, if you could valorize those cars? So they weren't built to last for a few years and then get what we could out at the end, but they were built to be as useful and as capable for as long as possible. And when the technology is superseded, the materials feed back into the economy. Same in the biocycle, absolutely the subject of this conference. What if all biological materials flowed back into the economy? What could that look like? And I'll give you an example of a project on the technical side of the circular economy. So these are plastics, metals, polymers. I'll just give one because the conference is very much about biological. But this shows a systemic change in the way the economy functions. Normally lighting we buy, and when it breaks we throw it away. And some of it gets recycled. In this instance, a company in the Netherlands spoke to Philips and said, we want light in our offices. We don't care how you provide it. We don't want to own the lighting. We actually don't want to pay the electricity bill. Can you provide us with light in our offices? And Philips said yes. They developed a system called Paperlux. They delivered 450 lumens at desk height, which meant that they built the best lighting they could that would be as efficient as possible. They would change the bulbs out when they had more efficient technology, or the entire light. That light would then go back into Philips, who know exactly what's in it, who know exactly how to recover the materials because they designed it, and then those materials could flow back into the economy. It's a change in design, it's a change in business model, it's a change in energy efficiency. The whole system changes and involves every different department within Philips. Not just the item itself, not just the light, but how the light fits within the bigger system. It really is true systemic change, not tinkering at the end, but going to the beginning of that system and working out how that can really run. And on the biological cycle, talking of these big global material flows, for billions of years, natural materials have gone back to the earth, and we've broken that cycle. In the developed world, how much of that biological material goes back to the farms? How much of the nutrient, the fertilizer that could be, goes back into the earth? Very little. Because that cycle has been broken, not through any malintent, but just because our economy has evolved, we've become more efficient, and we've built a system that is brittle and a system that can't run in the long term because it's linear in the way that we take those materials, we take that food stuff, and we don't replenish the system, we don't create the loops. And to look at the circular economy in slightly more detail, you have the technical side on the right. That's the lighting solution. That's vehicles, it's trains, it's buildings, it's anything that doesn't biologically compose. And then on the left-hand side, you have biological materials, timber, cotton, food waste, anything that fits within that natural cycle that can biodegrade and feed back into the economy. You'll see in there on the left-hand side, you've got extraction of biochemical feedstock, anaerobic digestion biogas, also cascading. The idea that if you take a piece of tree, you could burn it for sure, and you could heat your home or your office, but you could also take the tree and turn that into a table. And then you could take that table when it's come to the end of its life and chip it down and turn it into some form of chipboard. And at the end of that life, you could chip that down and turn it into particle board. And if it's designed correctly, at the end of its life, it could go into a biodigester, be anaerobically digested, and you can recover all of those materials, heat, light, and fertilizer. So it's looking at how can you keep that product timber at its highest value at all times. Another example. The right-hand side, just one point, you have at the outside loop recycling. The circular economy is not about recycling. That is the loop of last resort. So much more of the value of the circular economy lies on the inner loops, on reselling the same product, maintaining the same product, like a watch that's beautifully designed that can be maintained and kept within the economy for a long time, rather than building one that lasts for a few years that ultimately will always become waste. And so much more of that economic value lies in those inner loops. And to find this out, we went to McKinsey as a foundation. We launched 4.5 years ago, and 6 months in, we went to McKinsey saying, we'd like to understand the economic drivers of a circular economy. If we can shift to these circular models, these circular business practices, these case studies, these ideas, this circularity, what's the value to the global economy? The first report, we looked at medium complexity goods within Europe. The second was FMCG, including food, packaging, products that cycle in less than 1 year. The third was looking at streamlining global supply chains. The third we released in conjunction with the World Economic Forum as the idea of the circular economy was taken up. Those 3 reports showed a value in excess of $1 trillion moving towards more circular principles. Hugely profitable when you compare linear to circular today without any changes in legislation. And just a couple of points on that second report, FMCG, because it's very valuable to this audience. This is a symptom of a system that doesn't work. Everything in there should have value. The plastic should have value, the biological material should have value. But it's in a place where that can't be valorized, and it's been designed in a way and fits within a system that cannot valorize it, so we end up with waste. But it all has value. One of the questions we asked McKinsey in the second report was, what if you could collect together agricultural waste, farm waste, human waste, and food production waste? What if you could collect that, and what if you could feed that back into the chemical fertilizer system? Could you actually replace current chemical fertilizer use in 1 year? We didn't think it was possible. Their answer came back saying, yes, you can, by 2.7 times. Now, arguably, we don't do that at the moment, but it was an interesting statistic to throw in. 1 ton of food waste, $6 of fertilizer, $18 of heat, and $26 of electricity in every single ton. That would be a figure for the UK. Think about cities as aggregators of nutrient. Masses of nutrient from farms all over the world go into cities. Now more than half the population lives within cities. The opportunity of the nutrient flows within those cities is absolutely huge, not just for urban farming, but also for getting that nutrient back out to farmland to produce fertilizer for the future. And then just a few case examples to wrap up. A company in the US built a piece of packaging to replace styrofoam. Styrofoam will always be waste. This is built out of agricultural waste material. It's mycelium, it's mushroom compound. It replaces styrofoam on price parity with styrofoam, has huge clients now like Steelcase and Dell. That will never be waste. Whether it fits in an anaerobic digester or an industrial system or ends up in a hedge in a field, it will never be waste because it's designed for the biological cycle. Textiles that are made in a way which are non-toxic, biodegradable, the dyes in them are non-toxic, and the waste material from that factory is not waste. It is the wrong word because it's sold to farmers to cover their crops to help the seeds germinate more quickly. And the entire material, which you could actually eat, biodegrades into the earth. Systems like Solar Orchard, where you can regenerate desert land through putting solar panels over the land, which shade the land, which allow water to be trapped in the land when the water arrives, and it allows plants to start growing. To actually regenerate lands, and this is one of the bases of the circular economy, you can be restorative and regenerative through rebuilding these flows. It allows you to restore land around the world. And just to end, I think, at the foundation, we work in education, we work with business, we work on analysis and insight. But the most amazing thing for us as a team is we work on opportunity. We genuinely believe that the circular economy is a massive opportunity globally, not just economically, but for us to be restorative and regenerative across the world. Thank you.